Good morning, Year 8. Welcome to our first video lesson. So this lesson is all to do with introducing Pythagoras' theorem. So first of all, a lot of you have seen this already because we did cover it on our very last lesson together before the school closure. But I am aware that lots of people missed that lesson due to self-isolation and things like that. So I'm going to recap it, and also it's been a few weeks anyway, so it's going to help all of us if I just quickly recap it. Alright, so bear with me if you remember it, but I think a lot of people could do with this recap. So, first of all, we have an image in front of us. So it's a right angle triangle with three large squares sticking out from the sides. So let's say that this side A, it has a length of 3 units. This side B has a length of 4 units, and then this length that we're calling C has a length of 5 units. Right. So now let's consider these larger squares. So this large square is made up of 9 smaller squares. So I can say that A, so length A squared, so that 3 squared makes 9. Okay, next, let's consider this larger square. So it's made up of 16 smaller squares. So 4 squared makes 16. So I can say B squared is 16. And now finally, let's consider this larger square. So the biggest square on here is made out of 25 smaller squares. We know that because C squared, so 5 squared is 25. What I want you to do now, pause this video and tell me if you notice anything interesting about these numbers on our screen. Okay, so what's interesting about these numbers is that the 9 and the 16, they add together to make 25. Okay, that's not just a coincidence. This is true for any right angle triangle. No matter what the lengths are, as long as we have a right angle triangle, these two smaller sides squared will add together to make the larger squared. So what I've highlighted here, A squared plus B squared equals C squared. This is a very, very famous piece of maths. This is called Pythagoras' theorem, and it was invented by this guy, and it's named after him. His name was Pythagoras, and he was around in 500 BC, and he discovered this piece of maths. So A squared plus B squared equals C squared. So the two smaller sides squared always equal, they add up together to equal that larger side squared. Okay, before we start using Pythagoras' theorem, and before I show you why a mathematician would use it, I just want to point out that C, so when we label these sides, C is always that longest length. So that diagonal, we call it the hypotenuse, and it's the longest side. And you can picture it as the side that's opposite the right angle, if that helps. Right. So when we label this hypotenuse, like I said, the hypotenuse, the longest side C, is just this length opposite the right angle. So this one would be C. So can you pause the video and see if you can think which of these three lengths would we label C? Okay, so for this triangle, the longest length, so the length opposite the right angle, is this one here. So we would call this one C. And A and B, it doesn't matter which lengths we label A and B, as long as we've got the C one as the longest side. Right? So, for these triangles, again, could you please pause the video and tell me which lengths do you think should be labelled C? So remember, C must be the longest length opposite the right angle. So pause the video and I'll show you our C lengths afterwards. Okay, so these are the lengths that we need to label C, and then our A and B, it doesn't really matter what order A and B are as long as C is labelled correctly. Okay, so now that we know how to label a triangle, let me show you what Pythagoras' theorem is actually used for. Right, so in this first question, we have a right angle triangle. We know 2 of the lengths, but we have a missing length. Pythagoras' theorem is used to calculate missing lengths in right angle triangles. So, for us to use Pythagoras' theorem, we need to label the triangle. We need to know what length A, B, and C are. So, always start with C. So, which is my length C? Well, C is the longest length, so it has to be this one here. And then A and B, this order doesn't matter. Let's call this one A and this one B. Okay, so using my theorem, I know that A squared, so instead of A, we're calling it 4, so it's 4 squared plus b squared, so I'm calling it 3 squared, because we called this length 3, that equals c squared. I don't know what c is yet, so I'm just going to call it c, and I know it's c squared. So I've taken my theorem, and I've substituted in those two values. Alright, so let's do some maths. What do I know about 4 squared? Well, I know that 4 squared is just 16. So 4 squared is just 16, and I know that 3 squared is 9. And I still have no idea what c is, so I'm just going to leave that as c squared for now. Alright, let's do some more maths. 16 plus 9. I know what 16 plus 9 is. 16 plus 9 is 25. Easy. Okay, so I'm getting very, very close to my answer actually. So this is telling me to find c, so something squared makes 25. So this missing length here, so that's c, if I square it, it makes 25. What number squared makes 25? For me to work that out, all I need to do, I'm going to do the opposite of squaring it. I'm going to square root both sides. So that tells me that c is 5, because the square root of 25 is 5. Okay, so you're going to try one now. I want you to pause the video and see if you can use Pythagoras' theorem to calculate this missing length. Okay, so to start off with, a squared plus b squared equals c squared. I need to label this triangle. Let's start off with c. So c is my longest length, so let's call it this one here. A and b, it doesn't matter which order, so let's just call that one a and that one b. Alright, let's make a substitution. Instead of a squared plus b squared, let's call it 8 squared plus 6 squared, because that's how we labelled our triangle. So 8 squared plus 6 squared equals c squared. Alright, let's do some maths. What is 8 squared? Well, 8 squared is 64, and 6 squared is 36. So let's just write that down. Alright, let's do some more maths. 64 plus 36, I know, is 100. So 100 equals c squared. So it tells me this missing length c, if I square it, that gives me 100. What number squared makes 100? Well, square rooting both sides, that tells me that c has to be 10 centimeters. So this missing length is 10 centimeters. I have solved the problem. Okay, so as I have attached in a PDF document on Google Classroom for you, I want you to work through this as your classwork for today, please. So question 1 is very, very similar to what we just done. And then in question 2, it says round your answers to 1 decimal place. So all that means is that your answers, they're not going to be whole numbers. They're going to be quite complicated decimals. And all that means is that you need to use a calculator for those questions. So just find the square root button on your calculator whenever you need to. Alright, and I'll pause the video now. So work your way through it. And then in a few seconds, I'll show your answers up in this video. Okay, and then these are your answers to the classwork for today. Any questions, any problems at all, please just send me a message on Google Classroom or send me an email. Okay, thank you very much.